Okay, let's dive right into this. You know, we've all seen these incredible high-tech prosthetic hands that look like they're straight out of a movie. But the truth is, controlling them, making them do simple, everyday things, is still a massive challenge. So today, we're going to explore how a whole new way of gathering data could finally teach these artificial hands how to act in the real world.
So what we're breaking down here is a really fascinating piece of research from Daniel Andreas and his team. They've put together this groundbreaking new database that might just be the key to unlocking the true potential of prosthetics.
And that really brings us to the central question, doesn't it? With all of our amazing technology, why is it still so incredibly difficult to make a prosthetic hand that moves with the same fluid, intuitive grace as a human hand? Well, the issue really comes down to a huge disconnect between how these hands look and how they actually function. On the outside, they look absolutely incredible, but when you get to the actual control, there's a serious limitation. And look, this isn't just a technical problem. As the researchers themselves point out, this control issue is a major reason why many amputees actually choose not to use these advanced devices. You know, the ones controlled by the electrical signals from your muscles. So this is a deeply human issue.
Think of it like this. It's kind of like having a smartphone that only lets you open a few specific pre-installed apps. You can't just browse the web or type freely. That's really the state of many prosthetics today. They're stuck with this limited menu of gestures, which, let's be honest, just isn't how real life works at all.
Okay, so why this limitation? Where's the disconnect coming from? Well, the core of the problem is in how we've been teaching these artificial hands. The data they learn from has this fundamental flaw. It's all created in a sterile lab, not in the messy, unpredictable real world.
And this slide just lays it all out so clearly. You see, lab data is super clean and controlled. Participants start from a specific resting position, they do simple little motions, and they get regular breaks. But real life? Ha! It's messy. Our arms are in all sorts of weird positions, our movements are complicated, and we definitely don't stop for scheduled breaks.
This analogy just hits the nail on the head. Training a prosthetic hand only on that clean lab data is exactly like teaching someone to drive in an empty parking lot and then expecting them to be able to navigate chaotic, rush-hour city traffic. You're just not preparing them for what they're actually going to face.
So to solve this, the researchers created a totally new kind of data set, one designed from the ground up to capture all that real-world complexity. So let's meet the hero of our story, the MyoKi database.
MyoKi is basically designed to be the bridge over that gap between the lab and daily life. It doesn't just record simple little gestures. It records the complex, continuous movements that we all perform without even thinking about it. It does this by capturing both myography, that's the signals from our muscles, and hand kinematics, which is just a fancy way of saying the precise motion of the hand and fingers. And to build this thing, they started with a really diverse group of people. They brought in 35 different participants, covering a whole range of ages. And get this, they didn't just have them do one or two simple things. Each person performed a staggering 74 different real-world tasks. And to make sure the data was super solid, they repeated that entire sequence 6 times. I mean, the sheer scale of this is just incredible. To get the full picture, they captured an unbelievably rich set of data from the arm using a whole combination of sensors. So they measured the electrical buzz in the muscles with EMG, the motion and orientation of the arm with IMUs, and even the changes in muscle pressure with something called FMG. And the tasks they did weren't just simple flexes. Oh no, we're talking about real-deal activities that show all this complexity. Things like picking up a key, which uses that delicate tripod grasp, or lifting a heavy laptop bag, which needs a strong hook grip, and even really complex two-handed jobs like tying and untying shoelaces. This is exactly the kind of messy, real-world data that's been missing all this time. So they built this incredible new database, but honestly, the most fascinating part is what happened when they actually put it to the test. The results were, well, pretty surprising, and they reveal exactly why MyoKi is such a big deal. So let me ask you this. Think back to school. If you get a lower score on a much harder exam, does that mean you know less? Or could it actually mean the exam was just a better, more challenging measure of what you can really do? Just keep that thought in your head for a second. Okay, so when they tested a machine learning algorithm, it got a pretty high accuracy score, 0.87, on one of the older lab-based databases. But on their new, much more realistic MyoKi database, the score dropped.
pretty significantly, down to around 0.69. Now, at first glance, you might think, oh, that looks like a worse result.
But it's not. That lower score is actually the proof of success. It means the MyoKi database is a much harder test, precisely because it captures the true messiness and complexity of real-world movements. It's a better, more honest benchmark for developing control systems that can actually work outside the comfort of the lab.
So, what does this all mean for the future of prosthetics? I mean, what's the big takeaway? This new database doesn't just improve on the old ones, it gives us a completely new foundation to build the next generation of artificial hands.
And this slide just lays out the roadmap perfectly. Step 1, you capture realistic data, which is what MyoKi does. Step 2, with that great data, you can train smarter, more robust algorithms. And step 3, those smarter algorithms will finally let us build truly intuitive prosthetic hands that can handle the challenges of everyday life.
You know, this research doesn't give us the final answer, but it gives us one of the most important tools we've ever had to get there. It really leaves us with this tantalizing question. Now that we have the right kind of data for them to learn from, how long will it be until an artificial hand can pick up a key, tie a shoelace, or lift a bag, just like our own?